Hi, my name is Gabe. For this problem, we're asked to use this formula to find the cube roots of 8 times cosine of 2 pi divided by 3 plus I sine of 2 pi divided by 3. Now let's begin by noting that in our problem, our r is equal to 8 and the angle theta is 2 pi divided by 3. So let's begin by finding our roots in terms of k. So for our problem, our zk is going to be the cube root of 8 times cosine of our angle, which is 2 pi divided by 3, plus 2 pi times k, and this is all divided by 3, our n value. And here we're adding I times sine of our angle, 2 pi divided by 3, plus 2 pi times k, all divided by 3. Now this will simplify to 2 times cosine of 2 pi plus 6 pi k, all divided by 9, plus I times sine of 2 pi plus 6 pi k, all divided by 9. Okay. So now, let's begin finding our roots. The first root we're going to want to find is going to be z sub 0. So here, our k value is 0. So what this is going to be equal to is 2 times cosine of 2 pi divided by 9 plus I times sine of 2 pi divided by 9. So this is the trigonometric form of the solution. So this is the first root in part A. Now to write this in standard form, we can use the distributive property and write this as 2 times cosine of 2 pi divided by 9 plus 2 times sine of 2 pi divided by 9 times I. Now using a calculator, we'll evaluate 2 times cosine of 2 pi divided by 9 and 2 times sine of 2 pi divided by 9. So 2 times cosine of 2 pi divided by 9 is approximately 1.53. And 2 times sine of 2 pi divided by 9 is approximately 1.29. So we have the trigonometric form as well as the standard form. Now to find z1, we'll substitute 1 in for k. So here we'll be looking for 2 times cosine of 2 pi plus 6 pi divided by 9, which will be 8 pi divided by 9 plus I times sine of 8 pi divided by 9. So this here is the trigonometric form of the root, and we can use the distributive property to find the standard form of the root. So using a calculator, we'll find 2 times cosine of 8 pi divided by 9 which is approximately negative 1.88. And again, using a calculator, we'll find 2 times sine of 8 pi divided by 9, which is approximately 0.68. So there we found our first root and our second root in both the trigonometric and standard forms. Now let's find the third root. So we're looking for z sub 2. So here we'll want to substitute 2 in for our values of k. So this is 2 times cosine of 2 pi plus 12 pi, which is 14 pi divided by 9, plus I times sine of 14 pi divided by 9. Now again, using the distributive property, we can find this in standard form. So first, we'll look for 2 times cosine of 14 pi divided by 9. Which is approximately 0.35. And 2 times sine of 14 pi divided by 9 is approximately negative 1.97. So there we have the trigonometric forms as well as the standard forms of each of the roots. Now for part C, we're asked to graph all 3 of the roots. So let's consider our complex plane, where we have the real axis and the imaginary axis. So our first root occurs at approximately 1.53 on the real line and 1.29 on the imaginary axis. So let's say this is 1 and 2. So we'll be at approximately 1.5 on the real axis, and we're going to come up 1.29 on the imaginary axis. So our first root, C0, occurs right there. Now our second root happens at negative 1.88 on the real axis and 0.68 on the imaginary axis. So we'll come to the left, negative 1, negative 2. So coming over negative 1.88 on the real axis and coming up 0.68 on the imaginary axis puts us here. So here is our second root. Finally, for our third root, we're at 0.35 on the real axis and negative 1.97 on the imaginary axis. So we can already come over 0.35 on the real axis and coming down 1.97 on the imaginary axis of negative 1, negative 2, and our third root will happen here. Thank you.